Hi everybody, here we're going to go over the theory for the centripetal force lab. So first thing is that um, if you have a string and the string has a length L and you tie a mass to it and then you whirl the mass in a circle, um, so the mass is going to move in a circle with the radius r, which is going to be the same as the length of the string. And you, in order to keep the mass moving in a circle, you have to pull the string towards you. So you have to exert a force towards the center here. So this is called the centripetal force, and that's going to keep the mass moving in a circle. And so this circle is going to have a radius r, and if you and the force they exert points towards the center of the circle, and that's the centripetal force. And if you were to cut the string, at the instant when you cut the string, the mass would fly off with the velocity v, and the velocity would be perpendicular to the radius of the circle. And so from there, we have the equation for the centripetal force. The centripetal force is defined as the mass of the object moving in a circle multiplied by the velocity squared, but the velocity has to be the velocity perpendicular to the circle, and divided by the radius of the circle. So that is the basic equation for the centripetal force. But now let's apply this to our lab, for today's lab. So what you're going to do today is that there's going to be a tube, and there's going to be a string, and the string is going to pass around the tube, and there's going to be two masses. So there's going to be one mass up here, and there's going to be another mass at the bottom down here. So the mass at the bottom, I'm going to call this the hanging mass, and the mass that's moving, and this other mass here, this is the mass that you're going to whirl around in a circle. So this mass, I'm going to call that one m-bob. So this is the one that's going to move around in a circle. Okay. So what you're going to do is you're going to, in the simulation, you're going to grab on to this tube here, and you're going to whirl your hand around, move your hand around, and that's going to cause this bob to move around in a circle. So there's a couple of things that you're going to measure. So let me just get rid of some of these extra things here. So one of the first things that you're going to measure is from this axis here, you're going to measure the radius of the circle. So you're going to measure the radius r, and you're also going to measure the mass of the bob and the mass and the hanging mass. So the next thing that you're going to do, so these are just the basic measurements, but now the physical part, this is what you're going to do. So again, I'll redraw this here. You have your tube, and you have your string, and you have your hanging mass, and you have your bob. Alright, so you're gonna whirl this thing around in a circle, but as this thing whirls around, it might whirl too fast for you to see, to gauge the motion. So what you're gonna do actually is you're gonna whirl this bob around, and you're gonna whirl it around a certain number of times. So you're gonna count the number of revolutions, or the number of times that this bob whirls around for a certain amount of time. So you're going to measure, so just put it here. So what you're actually going to measure is for a given number of revolutions. So let's say that it's 25 revolutions. You're going to count how much time it's going to take for this bob to go around 25 times. So I'm going to call that the time, or the total time to make those revolutions. And because this involves a reaction time, you're going to repeat this 3 times, but we'll get into those details in the instructional part of the video, or in the video that talks about about the instructions. But for now, this is just a theoretical part. All right, so you can measure the mass of the bob, you can measure the hanging mass, you can also, and for a given number of revolutions, you're also going to measure the time for the bob to go around the circle. And that is going to complete the measurements. And now let's see how we can relate that to the centripetal force. First thing is that if something moves around in a circle, the time for the object to move around in a circle once, or the time to make one full cycle, that's the period, which is going to be the time for one revolution. But in our case, again, it might be too fast for you to see the time to go around once. So what you're actually going to do then is to let the bob go around 25 times. And in this case here, the period is going to equal the total time that the bob is revolving divided by 25. So these are calculations now. So based on your measurements for time to move around in a circle, you're going to calculate the period using this equation. And next, recall the centripetal force equation. Up here, it involves the velocity. So you can actually use the time to measure the velocity. And let's see how to do that. All right, so looking at this from the top, this bob is moving around a circle with a velocity v, and the circle has a radius r. So velocity is going to equal distance over time. In this case, though, if the distance is if it goes around in a circle once, the distance is going to correspond to the circumference of the circle, which is going to be 2 pi r, and the time to go around the circle once is going to correspond to the period. So you can also calculate the velocity of the bob as it moves around a circle using this equation, which is going to be, well, let me put it down up here. So the velocity of the bob that moves around a circle, v perpendicular, is going to be defined by this equation. So all you need to do is measure the radius of the circle, and up here the data that you got for the time to go around the circle 25 times. You'll use that to calculate the period, and once you've gotten the period, then you can calculate the velocity for the bob to move around a circle. And from there, you can calculate the centripetal force using the equation from above. So the centripetal force is going to equal the mass of the bob multiplied by the velocity that you just calculated, this one up here, squared, and divided by the radius of the circle. So that's going to be one way to calculate the centripetal force, but we're also going to calculate it another way. So let's see what the other way is. So as you're whirling this bob around in a circle, what's keeping the bob from flying out? Well, the bob is whirling around a circle, but it's connected to this string here. And the string is connected to the hanging mass. So actually in this case, the object that is applying the force to keep the bob moving around in a circle is the weight of the hanging mass. So just Fg hang, which is going to be the hanging mass times g. So this is another, this is something else that you're going to calculate. So you're also going to calculate the hanging mass's weight. So Fg hang is going to be mass hang times g. times g. And both of these are going to represent the centripetal force. So in this case, this is the centripetal force derived from you measuring time that the bob moves around in a circle in a period. And this one here, this is the centripetal force in terms of the object that is actually exerting the force, which is going to be the hanging mass. After that, the experiment repeats. So the next part of the experiment, so there's going to be, I guess, 3 parts. So for part 1, this is going to correspond to part 1 here, what we just done. For part 2, you're just going to change the mass. And you're going to repeat the experiment. And in part 3, you're going to keep the mass constant and you're going to change the radius that the bob moves around in a circle. But essentially, we've covered all the physics that we need for this lab. So again, what you're going to do is you're going to whirl a bob around in a circle, and as a bob whirls around in a circle, you're going to count how much time it takes for the bob to go around 25 times. And once you've gotten that time, then you can use this equation to calculate the period, or the time for the bob to go around once. And once you've gotten the period, you can use this equation to get the velocity that the bob moves around the circle. And once you've gotten the velocity, then you can plug that into this equation to get the centripetal force. And next, you can also get the centripetal force using the weight of the hanging mass. And you'll complete the experiment by just comparing these two, by taking a percent difference between those two values. So that completes the theoretical discussion for the centripetal force lab.